And welcome to the 2016 edition of our Cardano Developer Office Hours. I'm Darlisa. I will be your host today. So whenever you are building the apps, integrating APIs, or just curious to learn more about Cardano ecosystem, you're absolutely in the right place. If you haven't yet subscribed to our calendar, now is the time. Make sure to click the link that's in the chat so you keep up with the upcoming events. And here you have a little bonus. So if you stick around until the end of the session, we'll be sharing 100% discount code for our CBCA XL. So now let's dive into our main session. You'll be learning about Heron today with none other than Michiel Bellen. Michiel will walk us through why Heron was built, how you can deploy it from scratch in just a few minutes, and how it helps you to handle your queue while unlocking real-world use case. So whether you're a developer looking to streamline transactions or a builder searching for easy ways to integrate into Cardano, this session will give a practical insight how you can put into working away. Without further ado, Michiel, the floor is yours.
Thank you very much. Hello, everyone. Let's start off with a little presentation here. Share my screen. Can everyone see it? So let's start a slideshow as well, make it a little bit more interactive. Can you see my screen?
Oh, good.
Cool. Heron. It's a side project that I started in my free time because I saw a need for it. I built several platforms on Cardano myself, and I always ran into the same issues. So I thought, why not make a tool for it that solves it for myself and for others forever. At my work at Cardano Foundation, I also encounter companies, and they always have to build their own things from scratch. So I saw a real need for it. Of course, Heron, the name itself, is not very explanatory what it is, what it does. So I was suggested to maybe looking for different names, calling it Transaction Generator Extreme. For short, you can go call TransGenX, which is very 2025. So why? Like I already said, I saw a need for it. We want to fill blocks. We want to have diverse transactions, and we want to have enterprise adoption. Of course, that's bold goals, easier said than done. Especially if you're new to Cardano, there are some building pains questions that you run into. Like for infrastructure-wise, do you run your own node? Do you run your own DB sync? Do you run GraphQL on top of it, or do you run BlockTrust API on top of it? Which comes with its own pains in terms of like with hard forks or upgrades or just availability of the infrastructure, the cost of the infrastructure. So there's also other platforms. Do you query BlockTrust, Koios, Maestro? Do you query BigQuery that also has a Cardano dataset available? So there's all these questions that builders, newcomers, enterprises that come to Cardano have to struggle with, have to find their way. And I try to make it more just like an application on your phone, or just install it, deploy it, configure it, and use it. Same with libraries. There's still for newcomers, everybody still thinks, or 98% of the people that come to Cardano still think you need Haskell to build on it, which is not true anymore. There's a wide variety of JavaScript, Python, Java, C#, other tools, libraries available that make building on Cardano easier, accessible. But there's upsides, there's downsides to every library. There's complexity. Is it being maintained? So all of those questions are pains that enterprises and builders struggle with. And on top of that, if you have the right tool set available and you start actually building your integration, there's another level of pain that you run into, which some of the builders might recognize. If you build a Cardano transaction, just one, for example, if you start dipping your toes, you run into errors like bad inputs, value not conserved when you don't balance inputs and outputs, C too small if you like you set a static fee of 1.1 and or 0.17 ADA, and it's not enough because there's too many inputs or outputs. All of these things are a pain when you start building, especially if you build dynamic queues. I ran into that myself multiple times, even when building Heron. So that's something I tried to fix. So then if we do some simple math, if one company takes about 2.5 months to build their transaction processing engine and actually learn Cardano, and if we want to have 1,000 companies that go through this, it's 2,500 months, which equals to 208 years. So of course, we don't have that time. We don't want to spend that time. Nobody wants to spend that time. So how did we go about it? It's a simple Web2 API. Everybody knows how an API works. Every developer knows it. It's a simple Docker deployment. It's lightweight, so you don't have a full node. You just query Blockfrost. Even the free tier is enough. It does transaction chaining. So instead of having to do a transaction, wait for it to settle, and then do another transaction, like you'll see it in the demo. It just starts spamming out transactions faster than you can probably follow with the human eye. Of course, if you do that, there's also the question of the finality of a transaction. Like, is there a rollback? Did the transaction actually make it on chain? So I'm also using Aura from our beloved TX Pipe team to follow the chain and to determine if a transaction made it on chain. And if it didn't for a reason, be it a rollback, then we automatically retry it and resubmit it. So let's skip to the demo, switch to the demo. I'll share my main screen now. So everybody can access Heron. It's on GitHub. It's public. I'm sure you'll find the URL somewhere in the notes. If we look at the API documentation, which in the presentation also briefly saw, there's a few endpoints to list wallets, load wallets, query wallets, delete wallets, even generate a mnemonic. So for new people that don't have a mnemonic yet, they can generate it through Heron. Or you can also take a mnemonic from another CLI generated and import that. So then on transactions, pretty much the same. You can post a transaction and you can query transactions. You can generate policies if you want to mint assets as well. So if we focus on the transaction part for a second, it's pretty simple. Basically, it's you just post transaction instructions to Heron. You just tell it, use this wallet that you loaded through one of the earlier API points, create these outputs, attach this metadata, or mint this asset. All of these are optional, so you don't have to specify outputs, you don't have to specify metadata, you don't have to mint, but you can use them in a combination. So for example, if you want to mint assets, let's say you want to mint 1,000 Michiel coin and you want to distribute it to 50 people, you just say mint, policy, asset, quantity, and then in the outputs, you create 50 outputs to the 50 recipients, and it will do the mint and distribute those assets to those people. Same if you want to attach metadata, you don't have to specify any outputs, no inputs, it will automatically do that for you. So if you want to submit metadata for transparency reasons, reporting reasons, it will automatically check, okay, how much data are we attaching? How many inputs do we need? Select those inputs and then build the transaction with those inputs. I think that's it for now. So if we go back to GitHub, I also tried to build the documentation, the requirements, the functions that it currently has, and then also the installation notes of how to actually install it. So I'll switch to my terminal here now. At the top, I have a little screen to trigger. I'd have to change this.
Michiel, would it be
Yes.
possible to increase a little bit the size of the text there?
Yeah, sure. I can. Is this better?
Thank you. Yeah, looks better.
Increase this one as well. Oh. Where here? It's below. Clear. Write it correctly. I can't type anymore. Okay, there it is. Clear. So step one, we just clone the repository. Pretty simple. We move into the directory. You can see what's in the directory. So Docker files, Docker Compose, make environment, migrations, requirements for Python. So maybe on that as well, I chose to use PyCardano because it's pretty simple to read, very flexible to build. And then also the FastAPI library plugin component to build the entire infrastructure of Heron itself, or the structure of Heron. So next, we have to initiate the environment file. There's a simple Excel file that guides you through it. Postgres, if you want to access your database and query it yourself, you can configure the access, the password. Just not going to make this super secure because it's local. Then it asks you for a BlockFrost API key. Please don't steal this, otherwise I have to renew it. And then it also generates an encryption key. So it's best that if you do this, that you actually back it up, so you can reuse it later if you decide to reinstall your Heron. Why is this needed? Because Heron itself will store the mnemonics of the wallets that you load, and it uses this key to encrypt and decrypt when it needs it. This is because if you submit transactions, you don't want to go through the effort of signing each transaction, decrypting the key every time, or like using a spending password in an API payload or something. So this is all saved in the backend. Heron also does automatic network detection. So based on your BlockFrost API key, it will see if you want to connect to pre-prod, preview, or mainnet, or custom networks. I'm adding support for custom networks as well, which is not final yet. So next step is, we see the environment file there. There it is, just simple for environment variables. Next command is Docker Compose build. This will download all. Oh, this is pretty fast. Tested it before. That should be okay. We'll see. Otherwise, live troubleshooting is also fun. So everything's built, created, started. We can actually see the logs for the Heron API. And here as well, everything looks good. The API is available on port 8000. The environment variables, it loaded the SIP10 registry as well. So 39 labels are registered in SIP10. Reason why it does it is so that it actually checks if you want to submit metadata, that you're submitting a metadata label that's registered. Goal for that is to, one, make sure that people register metadata labels, which they use in Heron, and eventually also to do schema validation. So if you submit a metadata label like 721 for an NFT and you're not, the metadata you're attaching is not valid NFT format, that Heron will warn you and probably even refuse to like protect you from shooting yourself in the foot. So it says it's running, looking good. Eventually we should now on our local host 8000 or 8001, because this is how I exposed it in the Docker, have our documentation available. And this looks good. If we go to list wallets, empty response, or no wallets loaded. So let's get a wallet and load this. I actually generated a mnemonic before. This one you can take. It has 10,000 testnet ADA. So first one to take it, not during the demo, please, but afterwards you can take it. We just specify a name and a mnemonic. We say execute. The response looks good. We have an ID for the wallet. We have an address derived from the mnemonic. And if we go to our terminal, our logs, we can actually see that it spawns a backend worker, so a Redis queue that's ready and waiting for our wallet. So far, so good. Yeah, next step, we can actually, I'm going to put Cardano scan on the back end. No, C Explorer. Sorry, C Explorer. Sorry, Cardano scan. And we can see actually on pre-prod, the blocks look pretty empty. There's not a lot of things going on here. So this automatically refreshes in the background every 5 seconds. I'm going to make this a little bit smaller. You can see the blocks. So on the top terminal now, I will also move into the Heron folder where we have a tests folder with a transactions folder that has several Python files to test, just to trigger the API to test specific scenarios. One of them that I've mostly used is continuous trigger. So what that does is based on, so it's, for example, say Python continuous transaction pi, and then I specify a number, for example, 10, it will generate a payload for the Heron API, just normal ADA transactions, just taking random addresses. It sends it to itself for simplicity. So it takes the same address every time, then creates a random set of outputs, I believe between 1 and 5, but you can customize that in the Python script. So if we hit enter, we actually see it does 10 submissions to the API fairly fast. And then if you look in the Heron logs, here you see the posts still coming in, but the backend workers are also already executing things. So the first time it hasn't queried Blockfrost yet. So it says I have no UTXOs cached for this wallet. So I'm fetching them from Blockfrost. And then it starts building the first transactions. So here you see successfully submitted with the transaction hash. And then the next one and the next one. If you go all down, the first 10 are already executed. So you can see here as well, 49 seconds ago, the last block was minted with 9 transactions. Guess in the next block, there will be another one that's coming. So yeah, if we now want to make it a little bit more nicer, instead of doing 10 transactions, we do, let's say, maybe 10,000 is too much for the demo. Let's do 4,000. Now you'll see, seems like you're in the matrix. See a lot of API calls going through. So it's 700, 800, 1,000. So now you can have a coffee. Cheers. And 4,000. So all the API calls to Heron backend are finished. Everything's in the queue, and the queue keeps processing them. As you can see, it goes by pretty fast. And now we're waiting on the Explorer to catch up. 2 minutes ago, there was a block. It's pretty long for pre-prod. Come on, SPOs. Now it's loading things. There we go. So it looks like C Explorer wasn't continuously refreshing, but here we can see a minute ago we have 55 transactions, 83 transactions, another 83, 37. And those are, if we look in the block, for example, what's the top one? We see that it takes one input of 7,500 ADA, creates a change output, and it sends, it's not scrolling. There it is. Yeah, okay. So change output, index number 3, index number 0 is 4 ADA, 2 is 4 ADA, 1 is 2 ADA. So it does that dynamic number of outputs between 1 and 5, I think, and then also a dynamic number of ADA to each recipient, and then it adds automatically the change address. We go back. It will actually process the entire queue. So if you go back into the terminal, you can see that it's still spitting out transactions successfully submitted with transaction hash. So now it's sent to Blockfrost. Blockfrost makes sure that it gets sent to all the nodes, and then all the block producers will include them one by one, or in batches of 30 or more, 80, into blocks, and they get attached. So this is a simple demo. Of course, there are a lot more options to go through, but I think I'll pause there and see if there's any questions while we see blocks getting filled.
So the transactions are stored in the Redis, the internal Redis, or is it a database?
Can you repeat that?
Where do you store this the queue? The queue is maintained in the Redis, or you have a database? The Postgres database is the queue.
Yeah, indeed. So the backend database stores the instructions, and there is a signal sent to the queue saying process this ID. So the queue checks the database for the transaction ID, or like the transaction unique identifier, not transaction ID, gets the instructions, and then builds the transaction and submits it.
Mm-hmm. Okay.
Here you see one nice one, like 97% filled block with 204 transactions, minted by Cardano Foundation. Thank you, colleagues. So yeah, I think from an enterprise level, like how long have we been going now? I think, 15, 20 minutes or so. So we installed it, we configured it, and we're pumping out transactions. I think this makes it a lot easier for people. Of course, now the question for someone that builds on Cardano is like, what do I give? What instructions do I give? So if I want to mint NFTs, I just have to come up with the API payload that I have to send to Heron to say like, do this, mint these NFTs, attach this metadata, send it to these people. Or if you want to do open badges or carbon credits or reef transactions, or you just need the right recipe to build the result that you want. And then that's something that I also want to work on. Like I said, I call it a recipe. So I want to kind of build a cookbook of things you can build. And then we grow the Cardano standards. We make a recipe for Heron so that the people that want to bake the things just have to check the recipe, use the right ingredients, and then let's call Heron the oven to make the cake. Actually surprised that it like takes multiple minutes. I think it's on the Explorer side that because you always see like a bunch of blocks at the same time coming instead of one by one. On the previous C Explorer, that wasn't. But yeah, I think in short that's it. I also have some next steps. So yeah, testing outside of Happy Path, because I made it. My testing's not very. I don't find all of the bugs. So if we have people that test it and run into their own issues, feel free to create issues on GitHub. Reach out to me through Twitter or Discord or Telegram, and tell me what you need or what you're looking to do with it. So as well, the cookbook with the recipes as examples for NFTs, carbon credits, open badges, line tracking, reef transactions, you name it. And then I'm also looking at doing a CAP 10 update where we can actually, in a programmatical way, if we submit a metadata entry with a metadata number, that we can actually find a schema validator. So that's something that CAP 10 doesn't have right now. There's no way of going from 721 to CAP 25 in a machine understandable way. So that's it from my side.
Thank you very much for the great presentation, Michiel. I actually have one question that I would like to keep here in the recording that came through X, that came from Matthew, actually. And he was asking, what's the difference from Heron to the APIs available on the Ada Enview? I'll ping you there in the chat in case if you know we don't want to see the resources.
I think I saw it as well yesterday. And it's actually pretty funny. Like Ada Anvil reached out to us on Telegram, I think the week before Rare, so 2 weeks ago, saying, look, guys, we have a new product. It's the Ada Anvil API. Have a look. And I was like, hey, wait, this is indeed very similar. I think one of the biggest differences is that their API, they run their API and they expose it to their users, their clients. It has pretty similar functionalities, indeed. Define outputs, define mints, different API formats, but very similar functionalities. I think it comes down to in the way how you run it. So I'm not running a Heron service for the public. They don't have to ask me for an API key. This is intended for people to run themselves. So an enterprise that wants to deploy this in their landscape and maintain their own wallet and run it themselves. Whereas the Ada Anvil API is a service that Anvil offers to the wider public. It's a similar tool with a different implementation, I would say.
Perfect.
You always have different ways of same. Blockfrost kind of did the same. Blockfrost offers a service available to the public, but if you don't want to use Blockfrost API for reasons, then you can run it yourself. So they open source that implementation. There's a flavor for everyone, I would say, and I think Anvil's API is a different flavor for a similar meal course.
Yeah, probably depends on the requirements, right? So do you want to use this Blockfrost API, maybe have a license with them or something like that, or are you paying for a subscription? Otherwise, you have another option that where you can hire like the entirely service itself.
Yeah, indeed. Yeah. Do you buy your car? Do you lease your car? Do you rent a car? Do you Uber? Like it's good to have options. And I think Heron and Anvil API are a little bit brothers or cousins doing the same thing in a different way.
Cool.
Definitely.
Right. So before you finish up today, you have just 1 second. You have someone. Okay. Joining right now. So something that I would like to share quickly is just about our Cardano Academy. So for the ones that stayed until the end, here you go. So for whoever wants to learn more about blockchain or Cardano itself, we do have the Cardano Academy. That's a free course available for everyone. And as I mentioned in the beginning of the call, you're giving away 100% of the tickets for the CBCA exam. So here is the voucher code, as you can see, and here is just more information about the certification itself. So again, if you would be interested to learn more about blockchain and Cardano, here's the way to go. Just make note of the code here for taking our certification exam.